So hello everybody. Today we're going to be doing a nice limit problem. Namely, we're supposed to find the limit as x tends towards 0 of cosine x to the power of 1 over sine squared x. And first of all, let's just go ahead and state that it doesn't matter whether or not x is approaching 0 from the positive or from the negative direction. Why? Because both cosine x and 1 over sine squared of x are even functions. Okay? So both the left and the right limit, assuming they exist, and they do, will be the same, and that will be the limit that we have presented in this video. So first of all, what I'm going to do is I'm going to call this limit t. Now I'm going to take the natural log of both sides, and that will give me that ln of t is equal to the ln of the limit of this value. And limit and ln can change places, so that will be the same as the limit as x approaches 0 of the natural log of cosine of x to the power of 1 over sine squared of x. Now, by using the properties of logarithms, we can say that this is the limit as x approaches 0 of 1 over sine squared of x times the natural log of cosine x. And of course, this can just be rewritten as the limit as x approaches 0 of the natural log of cosine x over sine squared of x. Now let's just take a moment and plug in 0 into this expression. So cosine of 0 is equal to 1, and ln of 1 is 0. Sine of 0 is equal to 0, so sine squared of 0 must also be equal to 0, meaning we have the form, the limit of 0 over 0, which means this is a perfect candidate for L'Hopital's rule. So we're going to take the derivative of the numerator with respect to x and of the denominator with respect to x. So the derivative with respect to x of ln of cosine x is 1 over cosine x, but don't forget that we have to use the chain rule, so we have to multiply 1 over cosine x by the derivative of cosine x, so that's exactly the same as negative sine of x. And for the lower part, the derivative of sine squared of x is 2 times sine of x, and times the derivative, again we're using the chain rule, of sine of x, which is cosine of x. We can cancel out the signs because this is essentially a double fraction. Okay, yeah? And now we can just go ahead and multiply the outer parts, and that will go up, and that will be the numerator of our new fraction. So this is the limit as x approaches 0, and in the numerator we'll have negative 1, and in the denominator we'll have 2 times cosine squared of x. And now we can just plug in 0. Cosine of 0 is equal to 1. So cosine squared of 0 must also be equal to 1. So that means that this entire limit is equal to -1/2. So ln of t, which is where we started from right here, is equal to -1/2. So from here it follows that t must be equal to e to the power of -1/2, or this can just be rewritten as 1 over the square root of e. And remember that t was our original limit, so that means that the limit as x approaches 0 of cosine x to the power of 1 over sine squared of x is equal to 1 over the square root of e. So this is our final answer to this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.